All right, it's time to graph a rational function. So we're going to find the x-intercepts, y-intercepts, the vertical asymptotes, horizontal asymptotes, if any, and then we're going to use x values, test values, to know the behavior on either side of the vertical asymptotes. So let's start with horizontal asymptotes. Okay, so I'm just going to be gathering all the information, doing all the algebra over here in this workspace, and then we'll go to the right to graph on that coordinate plane. Okay, so horizontal asymptotes is the same degree, top heavy or bottom heavy. It's same degree, which means that we use the coefficients. So our horizontal asymptote is y equals coefficient of 1 here, coefficient of 1 here, and 1 over 1 is just 1. So when we go to graph, we'll have a horizontal asymptote at the y value of 1. All right, now we want vertical asymptotes. Okay, so vertical asymptotes is setting the denominator equal to 0. Add 5 to both sides to get an x value of 5 for our vertical asymptote. Okay, next I'm going to find x-intercepts. X-intercept is when y is 0. Remember, for x-intercepts of rational functions, you just need to set the numerator equal to 0. Subtract 2 from both sides. So we have an x-intercept. We only have one at -2, 0. Y-intercept is when x is 0. So we have a y-intercept at 0, -2 over 5. It gives us the heebie-jeebies to have a negative in the denominator, so I just brought it in front of the fraction or in front of the numerator. Okay, so let's go ahead and do or graph what we've got so far. I'm going to use red for those asymptotes. So we've got a horizontal asymptote at the y value of 1. And remember, asymptotes have to be dashed. And we have a vertical asymptote at the x value of 5. Okay, we have got an x-intercept at the x value of -2. And we have a y-intercept at 0, -2/5. So we can see clearly that one of our branches is here. I'm going to grab those 2 coordinate points that we just graphed. Now we have to figure out where our other branch is. You know our other branch is not here because then our graph would fail the vertical line test and we wouldn't have a function. So our other branch has to be on the other side of the vertical asymptote. It has to be either here or here. And we've got to figure out in which sector. And so the way you do that is you choose an x value on the right side, the other side of the vertical asymptote, and you plug it into your function to get a y value. So choose an x value on the right side of our vertical asymptote. So how about 6? So let's take our function and let's plug an x value of 6 into our function. So when x is 6, the output or the y value is 8. So this created another coordinate point for us. So onto our grid, We're going to plot that coordinate point at 6, 8. And now we know our other branch goes into this section. And that's it. Do I want absolute precision? No, I just want to know that you know where the asymptote should be, where the intercept should be, and where the branches belong. Also, we had one vertical asymptote, which means we have 2 branches to our rational function. Okay, let's try another example together. And let's start with horizontal asymptote. Remember, we're just doing the algebra right now. We're just gathering evidence to go graph. So we want to look at the degree of the numerator and the degree of the denominator for our horizontal asymptotes. So we've got same degree, top and bottom. So we use the coefficients. So the horizontal asymptote is y equals 4 over 1, which is just 4. Vertical asymptote is setting the denominator equal to 0. Subtract 2 from both sides, and now we've got our 1 vertical asymptote. So we know we're going to have 2 branches for our function. Okay, now let's find x-intercepts, and that's when y is 0, or setting the numerator equal to 0. Add 4 to both sides, divide both sides by 4. So we have x-intercept at 1, 0, and we only have one x-intercept. Okay, and now y-intercept, let's replace every x with 0. So we have a y-intercept at 0, -2. So the best thing to do now is to go ahead and plot what you've figured out so far, and then you can see what's happening so you can choose another x value to plug into the function to figure out where the other branch will go. So let's dash in those asymptotes first. We've got a horizontal asymptote at the x value of 4. And a vertical asymptote at the x value of -2. All right, next are intercepts. So we have an x-intercept at 1, 0. And we have a y-intercept at 0, -2. So we can see that one of our branches lives in this 4th sector, or at least just say this section. And when you draw that branch, you want to definitely go through those coordinate points, but you want to hug the asymptote, grab those coordinate points, hug the asymptote. In fact, that's what asymptotes do for us, is they just guide the behavior, the curvature of your function. Now we know the other branch is not going to go here, because then our graph would fail the vertical line test and we would no longer have a function. But is our other branch going to be here or here? And that's what we've got to figure out by plugging in an x value on the left side of the vertical asymptote to get a y value and create a coordinate point. So let's use, how about -3? So let's do r at -3. Let's take our function and replace every x with -3. -12 minus 4 over -1 is -16 over -1, which is +16. So we have a coordinate point when x is -3, y is +16. I think that's going to be off of our grid, isn't it? But when x is -3, here's -3 right here is -3, y is 16, which would be way up here. So we can see that our other branch is going to be in this section. And we can go ahead and just do a rough sketch. All right, I'm going to do one more example with you, and then I want you to try a few on your own. Okay, we're going to just gather evidence like we have been. Let's do horizontal asymptote first. So degree of the numerator is 1, degree of the denominator is 2. So this is bottom heavy, which means our horizontal asymptote is y equals 0. Vertical asymptote by setting the denominator equal to 0. Quadratic trinomial, so we're in automatic factor mode. That's not x plus 3, that's x plus 1. Let me check. See, I just in my brain real quick started to FOIL and realized I had written that incorrectly. So I think we're good now. Set each factor equal to 0. Subtract 1 from both sides. Add 4 to both sides. So these are going to be our 2 vertical asymptotes. So I already know that my graph is going to have 3 branches. You always have one more branch than the number of vertical asymptotes. All right, what do we do next? X-intercepts, and that's by setting the numerator equal to 0. Add 8 to both sides, divide both sides by 4. So we have an x-intercept at 2, 0. Y-intercept is next, and that's by replacing every x with 0. Negative 8 over negative 4 is 8 over 4, which is 2. So we have a y-intercept at 0, 2. And this is where we pause and we go graph what we have so far by starting with dashing in those asymptotes. Horizontal asymptote at y equals 0, which is just right on top of that x-axis. And we have vertical asymptotes at the x value of negative 1. And the x value of positive 4. All right, and next is intercepts. So I've got an x-intercept at 2, 0, and I have a y-intercept at 0, 2. Okay, so once we plot those intercepts, it is very difficult to tell how these branches are going to go. So we're going to have to plug in several x values to see what our graph is doing and where our branches live. Okay, I want to start with this middle part. I can tell that my function, remember we hug asymptotes, is going to grab that coordinate point and this coordinate point, but does it bounce off and come back up, or does it cross through? So that's what I've got to determine next. So I'm just going to erase what I've done here. I'll go ahead and replace those intercepts. What was that? 0, 2 for our y-intercept and 2, 0 for our x-intercept. Okay, so I know that I'm going to be above and hugging that asymptote, but what about below? So let's think about that. What about plugging in an x value of 3? So let's do r at 3 to create another coordinate point. And we get 12 minus 8 over 9 minus 9, and then negative 4. So we get 4 over negative 4 is negative 1. So we get the coordinate point 3, negative 1, which is here. So that helps us know that, in fact, we do cross through that x-axis and then we hug the asymptote. instead of bouncing off that horizontal asymptote or the x-axis and hugging the asymptote up top. Okay, now where are our other two branches? Are they here and here? Are they here and here? Are they here and here? We don't know yet. And we figure that out by plugging in x values to create coordinate points and knowing where those other branches live. And we know we have to have 3. So let's see. To the left of the vertical asymptote of x equals -1, let's plug in -2. So r at -2. So replacing every x with -2. And when you do that, when you plug in -2, you're going to get -8/3. So we have a coordinate point of -2, -8/3. So I'm going to go over to my graph. -2, -2, and 2/3. So about right there. So we know one of our branches lives here. And now we want to plug in a coordinate point to the right side of our vertical asymptote located at x equals 4. So how about we plug in 5? You can plug in 6 if you want to. And when you do that, you should get 2. So we have the coordinate point 5, 2 that we can plot on our graph. And now we know our third branch lives right here. And you just hug those asymptotes and make sure you grab that coordinate point on that curve. Okay, so that's what it looks like when you've got 3 branches. Okay, I want you on the next page, there's 2 examples, and I want you to try those on your own. Just do your best. Come back here, see what we did, use your notes, pause this video, try those on your own, and then come back and look at the answers. And I'm going to go ahead and sketch those. First, I'm going to write down all the information that you should have done. So we've got horizontal asymptote at y equals -1/3, vertical asymptote x equals 1/2, x-intercept at -3, 0, y-intercept at 0, 2. And then I also did another coordinate point by plugging 2 into the function to get another coordinate point to know where my other branch lives. Okay, and then graphing, I do my vertical asymptotes, my asymptotes first. And x-intercept, y-intercept, hug those asymptotes, and then plugging in that x value of 2, which is on the right side of the vertical asymptote, gave me another coordinate point to know that my other branch lives here. All right, and then the next example, just writing down the information first. Horizontal asymptote y equals 0 because we had bottom heavy. We've got 2 vertical asymptotes. We have an x-intercept at -2, 0, a y-intercept at 0, 2/3, And then I had to plug in some more x values and to get coordinate points. So I plugged in an x value of -4 to get 2/5. I plugged in an x value of -2.5. And I plugged in an x value of 2 to get a y value of -4/5. So again, you want to do all of that first. You want to graph this first, and then you'll know which x values to plug in to generate some more coordinate points. Okay, asymptotes. Intercepts. And then I needed to know the behavior of that center portion. And so that's where I plugged in -2.5 to know that I was below the x-axis before that x-intercept. And then I plugged in the x value of -4 to get that coordinate point to know my branch lived there. And then I plugged in the x value of +2 to know that my other branch lives down here. All right, that wraps up graphing rational functions.